In this short session, we're going to again go through how the t-statistic is presented in a journal article. This time we're going to focus more on tables in which t-statistic, the data might be presented. And so again, this is an article from Psychological Science. I'm a member of Association for Psychological Science, an excellent journal here. Here's a study. When does the future begin? Time metrics matter, connecting present and future self. And again, we're not going to go through the details of the article. We more just want to show you some of the results, how results can be presented here. So in this particular, for table 1, you'll see the data is presented here, and so one of the independent measures was just the time metric that was given. So in this case, the fine-grained time metric is they got an opportunity to talk about it in terms of days, or to think about it in terms of days, and the gross grain time metric was to think about it in terms of months. So we're not going to go through here and critique the article, but that's one aspect of that for how it is that they were trying to assess how people saw the future in essence. And so they were given 3 different scenarios here. You'll see the first one, John or Jane is shopping for a present for her friend's birthday party. When do you think the party is? And you see the fine-grained metrics. They gave a much shorter time frame, what most of us would probably think of. I would probably even think of even shorter than that. And then we've got our standard deviations, and then they give us a range of days. So it went from 0 to where they were buying it that same day, up to 14 days, about 2 weeks away. And then when they were given it in terms of, to think about it in terms of months, you'll see that the days was much larger here. We've got a much larger standard deviation as well, and our range is much larger too. And then they give us the differences here. So this is just the 31 here minus the 5.35, and give us the difference here, and then the standard deviation as well. And then here's the part, the t-statistic, so the t, and then this is our degrees of freedom, so there's 73 for the degrees of freedom, and then gives you the t-statistic of 23.47, really large, right? I mean, that's telling us that this mean difference is about 23.5 times larger than the difference you expect by chance. A huge difference that exists there, and it's negative, right, because they took this mean and subtracted this mean from it, which gave us a negative t-value for it. And then here's the effect size, the Cohen's d, which tells you that that's almost 6 standard deviations larger over here as compared to the other. And again, it's a negative just because they're focusing on this mean first and subtracting that mean from the mean of 5. And the key here in looking at these tables is they'll give you this the asterisk here, and you've got to look in the footnotes. And so the footnotes give you a lot of important information. So it describes the overall effect size and everything else that's here as well. But here it tells you that it's significant at less than 0.001 level. So typically, kind of a heuristic to use when you see these tables for statistics is when you see asterisks, typically that's going to mean, okay, this is a statistically significant difference. Okay, it's giving you a shorthand way of looking through this. And you'll see we have the same thing for the other ones. All 3 of them are statistically significant as listed here at a 0.001 level. And we all have there's all very large effect sizes for each one. One more table here gives you information, similar kind of thing as the one before. Suddenly, our degrees of freedom, the degrees of freedom are a little different from each one. That just tells you that some people maybe didn't fully respond to one of them, or somebody's data had to be thrown out. So that's one of the reasons why you've got somewhat different degrees of freedom, which means there's slightly different sample sizes for each one. And here you see 3 asterisks, and that's saying that the probability is less than 0.001. Actually, this is probably a little bit of a mistake, I think, within the journal article, because in essence, if these t-values are less than 0.0001, then that should be the case actually for these t-values as well, because these are all larger than that one. Not a huge error within it. Wouldn't change that much in terms. It wouldn't change anything in terms of how we interpret the data. And then again, it gives us the effect sizes here. So again, the key for this is look to see are there some symbols here. Asterisks are usually what's used, but sometimes they'll use letters or other kinds of things as superscripts there, and then make sure you always look at the notes here within the table, the footnotes that exist that'll tell you whether or not at what level something is statistically significant or what those superscripts mean.